Thank you, Charles, and thank you, all of you. As he said, 25 plus years. Actually, it's longer. I wanted to cut it down a bit. Otherwise, it makes me look really old. And as you can see, gray hairs, white hairs, no hair. And got a spare tire as well. This is as a result of going to lots of meetups, eating pizzas and sugary drinks, so beware. This is what you want to look like in your IT career. Think about it. I feel very privileged in many ways because I look at the speakers for this event and I think, why am I here? Those guys are wizards. I know nothing. And so thank you very much to the organizers for reaching out to me. And so the presentation today is going to focus on open source entirely, okay? Because no vendor talks allowed. You will see GridGain mentioned, I think, in about one slide. That's all, just at the beginning. And I'll refer you to some references, GitHub code as well, and some articles on DZone, which, again, if you're interested, you can follow up on and have a look at in your own time. OK, so now you may see me freeing up some memory on this machine. I apologize. OK, my usual laptop is not available. This is borrowed from my wife, and it's old. OK, so it's constrained. Mac OS uses half the 4 gig of memory that I've got. Years ago, when I started my career in IT, I worked for Reuters in London. And in those days, I was working with RSX11S. OK, so it's Macro 11 assembler. And we were really concerned about how efficient the code was. It was really tight. You develop the code in such a way because the environment is very constrained. These days, it doesn't matter. Everything's bloatware, right? Just add more memory, give it more disk, it's OK. Front-end tools, lots of great GUIs, fabulous. These things change over time. Just a quick show of hands. Any of you have heard of Apache Ignite? OK, 1 or 2. OK, so about 2 years ago, when I started working for GridGain, about a week after I started working for them, they said, we've got this event. We want you to go and speak. And I said, look, I've just started, but I'll do it. OK, so I spent a couple of days with my boss just learning about, we were talking about streaming, Flink, and Spark streaming, these kind of technologies. So actually, it's almost to the day, 2 years ago, I was actually here. Very same room, almost the same lectern. So kind of nostalgic. All right, then. So I think they've requested me to show this. And there we go. So machine and deep learning within memory computing. As I said before, GridGain gets mentioned once, that's all. OK, so in terms of the agenda then, what I'd like to do is talk a little bit about machine learning at scale. How does Apache Ignite support this? Now, it says demo. They're recordings. And again, I apologize. OK, normally I do live demos. But again, I'll show you where to get the software. OK, it's very, very easy to install. If you go to the ignite.apache.org website, you can download the binary or the source. OK, you can build it from source if you like. And as long as you've got Java, I think minimum Java 8, get yourself an IDE as well. You can load in the pom.xml file. It will create all of the demos for you. 5 minutes of your time, you'll have it up and running, no problems. All of the example code that's provided, you can run it directly from an IDE. You do not need a cluster to run it, although that's advantageous if you do have that. And we'll look at genetic algorithms briefly. I'll say something about the TensorFlow integration, principally because this was something added in version 2.7, just at the end of last year in December. And I think it was something that people were waiting for quite a long time. So we'll look briefly at that. And again, some resources into where you can find more information. OK, so why machine learning at scale? So typically, many of you data scientists, and by the way, how many of you class yourselves as data scientists? All right. And the rest of you, I guess, developers or perhaps people interested in the technology. I think for those of you who are not data scientists, if there's one bit of advice that I can give you, which is if you learn anything from today, if there's nothing that you've learned from the slides themselves, if you're not a data scientist, become one, OK? Find yourself a nice, high-paid job, earn lots of money, retire early, enjoy life, OK? Simple, OK? 10 years' time, there'll be no data scientists needed, OK? Because the technology is moving so rapidly. I mean, look at the announcements recently from Google, OK? It's steps, OK, going in the right direction. Things are becoming automated. Soon you guys will be replaced by software, right? It's just algorithms. They'll do your job even better than you can do it, all right? So at the moment, there's a great demand. So you guys have a chance, take that window opportunity. As I said, become rich, okay? And then, don't become like me, old and, grumpy and poor and all the associated things. So there we go. So, okay, back to the slides. So the key thing is that typically, and you may work at a small scale. I mean, you build your models, your test, train, kind of split, all these kind of things. Scikit-learn. But generally, you tend to do this on a small scale. Okay, so really, if you think about production environments, production systems, they tend to deal with a lot more data. You think about banking applications, for example, and one of the biggest users of Apache Ignite is a company called Sberbank, okay? Based in former Soviet Union, okay, Russia. They've got a system that spans 11 time zones, millions and millions of customers, 3 huge data centers, and they want to do an analysis of their customers, 360-degree view, find out what sort of services they currently have and where they can pitch new products and services to them. And there's all sorts of other things that they want to do, things like fraud detection, okay? We'll have a look at that shortly. So, the thing is that scalability, data exceed capacity of single server, burden for developers, okay? So you guys have to do a lot of work, in terms of cleaning the data, in terms of being able to run some of these algorithms at scale. It's a problem, right? Now, there are some technologies out there that can help you, okay? If you're a Spark user, for example, great, and then there's other things coming along. If you're working in any of the cloud-based environments, things like AutoML, these kind of things are nice tools that are in the works, and they will really help you, I think, moving forward. So, things to think about, okay? So it's still a lot to do in terms of cleaning the data and being able to do things at scale. There's the problem. And so typically, what happens in a lot of systems today, so if you look on the left-hand side, you've got your app, and then we've got typically relational systems, storing and processing working set. Okay, so you're able to read and connect to that. And then from time to time, you do an ETL, extract, transform, load. And then maybe you've got your machine learning or deep learning engine. You want to build, train your models. And then it's a kind of a cyclical thing. There's a fair bit of work that's involved. You've got multiple systems that you have to deal with. So the idea with this continuous learning framework, it just makes things a lot simpler for you. So essentially, your in-memory computing platform can do everything, okay? It can store the data, both in terms of acting as your system of record, okay, which typically what a lot of relational systems tend to be, but then at the same time, we can do a lot of processing as well. And then again, there's an iterative aspect to this because the model building is kind of an iterative process as well. This is the goal that we want to achieve. So no ETL. Now, in the past, before the machine learning capabilities were added to Apache Ignite, it was a problem because essentially you're stuck with this same problem that you see on the left-hand side. Now they've done a better job, and it's become easier. And going forward, I think it will become even more easier. But just watch this space, as they say. All right, so this is the kind of high-level architectural view of Ignite. And again, I'll kind of move between the two screens because it's a little bit hard to read. So at its core is this in-memory data store, okay? And historically, where this technology has come from is this class of product that's called in-memory data grid, okay? IMDG. There are other IMDGs out there as well, okay? Some of them are open source, some of them are commercial. You may have heard of them. Oracle Coherence, Hazelcast, for example, okay? Gemfire, Pivotal. So essentially, this class of technology is designed to solve two problems, scale and performance, okay? So the scale comes from the fact that it's horizontally scalable. Just add more machines, add more servers, okay? It will auto-balance for you, all the other things that you associate with cluster computing in terms of failover, recovery, those kind of capabilities, you get that with it. The other thing is performance. So in memory, that should give you a clue as to how it manages to do that, okay? To really get the performance levels up, is that it keeps things in memory. Each node has its memory, which is able to utilize for some processing operations, and that's where you get the performance benefit and the performance advantage. Now, over time, other things have been added as well. So one of the things that Ignite can do, for example, and it's true of other IMDGs as well, is that they can access external data sources. So if you're working with things like Hadoop or HDFS, Postgres, NoSQL databases, you can access those, be able to read the data, cache it into your in-memory data store, run operations at memory speeds, and that gives you great sort of performance boost. Looking slightly higher up, if we look at this level here above where it says compute grid, service grid, we've got, it says key value store, okay, so historically this is what it is. There are other great key value stores out there as well. Redis, for example, you may be using that. SQL 99, because whether you like it or you hate it, the truth is that today SQL is still very, very widely used. You get, if you need a SQL developer, you can find one very easily, okay? So SQL 99 support. Transactions, very useful. Give you an example of the usefulness of this. So I'm a big fan of MOOCs, massive open online courses. Last year, I think it was last year, there's a vendor's site that I went to. There's a particular course that I wanted to take. So I get my credit card out, I fill in the details, hit the pay button, and it says, and comes back and says, there is an error. And I thought, okay, transaction didn't complete, doesn't matter. Sometime later, I check on my credit card bill, and I've actually been billed. So I go to the merchant, and they say, we haven't received the money. I go to the bank and say, you've paid for this. Where's the money, right? That should not happen. There's an example of a poorly designed system, okay? So in the case of atomic transactions, ACID capability, as we often refer to with relational systems and other database systems as well, either something completes or it doesn't. It rolls back and you undo the operation. So in the financial world, this is very, very important. You have this notion of eventual consistency, but a lot of NoSQL products provide you. So eventually, things will become consistent. Now, maybe you're willing to take the hit and wait sort of 5 milliseconds or 10 milliseconds for that consistency. In some environments, is unacceptable. Okay, so it will do these atomic transactions for you. Okay, again, useful in certain scenarios. The rest of these things we'll kind of skip. Okay, machine and deep learning is the focus today. And of course, if you look on the website, which I'll show you a little bit later on, lots of vertical applications that you can have a look at, of which some examples are there. All right. Okay, so in terms of the continuous learning framework then, so what they've done is that one of the requirements from customers such as Sberbank was that, okay, can you add additional capabilities to this open source technology that allows us to do things like machine learning and deep learning with this technology? Can we, we want to be able to do useful things, run analytics, get some insights. So what they've done is, from the ground up, built and written these distributed algorithms. Okay, so all the standard things, k-means, regression, decision trees, and so on. As I mentioned, TensorFlow has been added late last year. Historically, Java, .NET, and C++ were the languages that were top level. There are these thin clients that have been added. So Python, for example, if you're a Python user, Node.js, PHP, these are available as well now. The nice thing about this is that if you download the source of the binary, on your laptop, you can run this stuff. Okay, as I said, you don't need a big cluster to be able to test this. Obviously, the benefits from this large-scale parallelization and the ability to run these algorithms at scale really comes into play when you do have a cluster of some size, okay? Because all of the load balancing, all of the tricks under the covers, everything is managed for you. You as a developer do not care. Or as a data scientist, you're interested in just running your models, and you don't care. Let the system manage all of those resources for you. That's the key thing here. Okay, and no ETL. So very important. So the thinking behind this is that support all this capability directly within the product. There is no need to take this out of here, then apply some other sort of third-party tools to be able to get some useful insights from the data that you already have. Okay. So one of the capabilities that you get with cluster computing is the ability that you've got primary copies of your data here in blue, okay? And you can create backup copies as well, here in gray, okay? So if you look at the distribution of this, then if in the event that we lose one of these nodes, let's say node 2 has gone down, okay, we still have a copy of 1 stored on node 4 and partition 0 stored on node 1, okay? So that's a very useful feature. So now, I think the key thing is that within distributed systems, generally it's good practice to have at least one backup copy. If you're particularly paranoid, you could store copies of all your data everywhere, all right? There's going to be some overheads involved, lots of data transfer, but for small data sets, that might work. For larger data sets, it's not practical, okay? Because you're shunting around a lot of data between your various sort of cluster nodes. Doesn't make sense, okay? You have to think about this. There are trade-offs, as always. Now, the reason I'm showing you this is that one of the things that you get with Ignite is that when you're doing a type of training, and you want to be able to create some models, is that with this capability of having backup data stored elsewhere, there's this notion of partition-based data sets. So let's say you've got a job that you've been running for, say, 30 minutes. And let's say some catastrophic problem happens. Bits of your cluster lost, either through communication or perhaps some hardware failure or something. And you go back and you have to restart your job. That's annoying, okay? It will save context and state and data for you, all right? If you've managed this and set this up properly. There is no need to restart your job. The system will manage those, the failure for you. It will ensure that your job runs to completion, okay? So perhaps it had another 30 minutes that it needed to run. That will be fine. It will do that. Okay? So in this case, what we're doing is saving context, partition data, and local ETL. Okay? So if necessary. So with this capability of having, storing this data elsewhere within the cluster, that really provides some significant benefits for us. Okay. So. Now, continuous learning, as you know, typically data, training, okay, iterate, solution. Perhaps we've got some new insights into that, and we go back and create some additional training. So algorithms and applicability, forgive me, touched upon this a little bit earlier on. This is fairly well documented. Text is a little bit small there. Don't worry, okay? So I'll point you where you can get a little bit more information about this. All the standard stuff in terms of classification, regression, clustering. Pre-processing capability is available as well now. The train test split you can do as well. So some of the articles that I wrote last year, for example, we had to use another tool to be able to handle that. Now you can do that directly within the open source project. So it's useful in the sense that probably for the vast majority of applications in the business world, certainly this will probably be good enough for 80 to 90%, right? There's nothing particularly exotic here. So if you're looking for something a bit more exotic in terms of algorithm support, this is not going to help you, right? Remember, the focus here is very much on the kind of problems that business has, industry has, enterprises have, and they want to be able to run some of these capabilities, get some insights, and get some results. Okay, so let me show you a quick example. All right, let's have a look. And I'll show you where you can get the GitHub code for this, by the way, and the related article as well. So one thing I wanted to try out last year, I mean, I'm not a data scientist, okay, but I thought I'll give it a go, okay, just to have a look at this. So I went to Kaggle. I downloaded some data that was available from this, I think it was the university in Belgium, where they did some work on collecting fraudulent transactions. Okay, so thousands and thousands of transactions, of which a very, very tiny proportion were fraudulent. And so I did a little bit of data cleaning on that, did some selection, and it was quite a problem because it's a very unbalanced data set. Right? So a little bit of playing around with that to try to get that into a reasonable shape. And then we just a little bit of Java code to process that, and then to run it, and then to get some kind of insights into how, get some sort of level of accuracy as how useful is this. So again, the code is available on GitHub. Let me just run this for you, okay? So we'll just have a look at this, see if we can blow this up a little bit. So see if that's a little bit for you. There we go. As I said before, usually I do this live, but sadly this machine is a little bit... OK, so there we go. So now we're running the Ignite client directly within the IDE. OK, you don't need a cluster, as I said before. This will work nicely, kind of standalone. If you look very sharply at the bottom there, it says servers 1, client 0. So essentially, we're just launching one cluster node, and it's just running the job for us, and it's being able to process that data. So it gives us some accuracy, precision, recall, Here's a confusion matrix, and based upon that data, actually that's not bad. Now, for an initial sort of first cut, for a guy who doesn't know anything about data science, I was able to do a little bit of coding, look at that data set, be able to do some selection of that, pick some values, and then get some reasonable results at the end there. Now, obviously, it's an iterative process. I'd probably look at where I can make improvements to it, go back, look at the code, look at the algorithm, what are the choices I made. That's very easy to do. But the thing is that this standalone it works, okay? And you can play around with this and test it out. And so the key benefit here is, again, the power that you'll get with this really comes at scale, okay? So if you've got vast amounts of data that you want to process, Ignite will handle that for you, okay? However, I've heard it said that data scientists typically, what you'll do your testing on your laptop, and it sort of fits within the capabilities and the environment that you have running on a local machine, and certainly in terms of model building and so on. And that's great. I mean, this will really help you in that respect. Okay, back here. Okay, so a little bit on. Okay, another thing then, genetic algorithms. So. When I looked into this was new for me. So this is kind of simulating biological evolution. So you've got this notion of genes and mutations. You're calculating this sort of fitness calculation. This seems to have good utility in some sort of commercial applications beyond just biology, okay? So there's a whole section in Wikipedia which I kind of went through when I was first looking at this, and it was kind of interesting to see some of the applications of this type of approach to many other different fields. And so Ignite will happily be able to run this as well. This was donated to the Apache Software Foundation by some external developers, so that's now ships as part of the official sort of library distribution that comes with this. All right, so I think there's a quick demo for this one as well. Again, very short recording. Let me close this one, and we'll have a look at that. Okay, there we go. Run this. Just zoom in and see what we can do. Okay, so it's a standard kind of hello world example. So we've got the string hello space world, all in upper caps, okay? And what we do, what we create in terms of the initial starting state is all the letters A to Z plus the space, okay? And then we say, okay, go around, iterate around, change, mutate, see if you can reach this state. Have you reached the answer we're looking for? If not, go around and do it again, okay? And keep going and keep going. So all it's doing is calculating this fitness calculation, and you can see it's already up to 141 generations, 161 generations. It varies from run to run a little bit. I think it just depends upon how much in terms of time and resources it needs. So there we go. Eventually, it's given us an answer which is matched, and it tells us that it's taken 321 generations fitness chromosome key. Okay, so don't worry too much about this. Although this is wrong here, it's actually done the correct match that we can see here. All right, so this is kind of, again, very useful. There are additional examples that come as part of this as well. Okay, so this is just something that's in the distribution, and you can, again, take the opportunity to customize that and play around with that in your own time. Okay, I'm sort of conscious of time. I want to leave some time for questions. Very briefly then, so TensorFlow. Probably some of you, maybe many of you are using this already. Very popular framework. Seems to be gaining a lot more popularity today. I think the world is kind of moving towards this. It kind of complements Ignite in many ways, okay? So that runs on a cluster. Ignite will run on a cluster as well. You can deploy TensorFlow on an Ignite cluster. Far less ETL, again, because the two are able to talk to each other. If you have the data you've got on a single node, it avoids this problem of having to shuffle data around. There is a roadmap associated with this, okay? So this is just the beginning. I mean, there is a lot of work that still needs to be done here, but the integration is already there. I mean, it's something that's usable today. You can start working with this immediately. And so part of the reason that the thin client was developed is because you guys like working in Python, okay? So a lot of these user tasks written in Python. Automatic creation and maintenance of the TensorFlow cluster. So Ignite will manage those situations where, for example, bits of your cluster are lost or go down, or communication is lost, it will manage that for you to ensure that this is working properly for you. And again, this, I can't emphasize enough this ETL cost, okay? So historically, this has been a big problem for a lot of companies, simply because shuffling data around, using a lot of mixture of tools to be able to get insights into data is really a big problem. I noticed that I think two of the presentations in this event today, people are talking about creating these pipelines. And if you look at the announcements just recently from Google as well, the ability to create these pipelines using the tools that they provide you, so that even users who are not particularly skilled or don't know very much about data science or machine learning or those kind of capabilities, that it makes them a lot easier for them to be able to do these kind of things. And we're minimizing these ETL costs, which can be significant when you're really dealing with large quantities of data. The other benefits, which we touched on, fault tolerance for both Ignite and TensorFlow instances. So again, if there are failures, Ignite will step in. It will ensure that the cluster is working properly. And that a couple of slides back, we talked about those partition-based data sets. Again, that comes into play because Ignite will manage those failures for you. Okay, very useful. So there is some demo associated with this, and there is something that you can get. And actually, if you look on the GitHub site for TensorFlow, there is a section there just on Ignite, okay, with some examples and some hyperlinks there as to where you can download and try this out. I think they use the MNIST dataset character recognition as the example. Okay, so before I point you to some resources and some other links, just to mention then, so massive scalability, horizontal, vertical, RAM plus disk, okay? So key benefits here is that, as I mentioned before, that because this is in memory, it can utilize memory super efficiently in terms of running operations at speed. Now, the thing is, you do hit some problems because ultimately, if there isn't enough memory to do the operations for you, then you will get these out-of-memory errors. So one of the things that Ignite has is this ability to persist data as well now. It's just one line of code in your Java. What essentially that does is that you get two benefits. Okay, the first thing is that anything that's bigger than memory, now you can store it to disk. Okay, just page in what you need. The second benefit is that if there is a failure, let's say there is a catastrophic cluster failure, let's say the entire cluster goes down, it's going to be a very costly operation to read everything and rebuild everything, from scratch if it's just memory-based. On the other hand, with database systems, there's a lot of expertise, knowledge, know-how that we know how to handle these kind of situations where there is some type of failure. There's logs that we can use. There is partition files that we can use to help recover the system. And again, going back to that example company that I mentioned a little bit earlier on, Spurbank. So one of the requirements, for example, they have is that in the event of some catastrophic cluster failure, things must be up and running again in 5 minutes. Right? And they're dealing with huge quantities of data. So some great benefits there in terms of using disk, extending that, treating it as sort of virtual memory, if you like. Zero ETL, again, touching upon this very important point. Train models and run algorithms in place. No need to export out and be able to use other tools. There's pretty good support where it is today. It will get better. Fault tolerance and continuous learning. Okay, so the benefits that you get with cluster computing is that, inevitably it tends to happen. And I think Google suffer from this as well, that if you look at clusters of machines, if you're using off-the-shelf hardware, chances are they're going to fail, and they're going to fail often. But if you've got enough of them, it's okay, it doesn't matter. I mean, the system can rebalance, it can maintain itself, it will do fine. You do not need anything really exotic to be able to run this. We talked about partition-based data sets as well as a major advantage. All right, now, a couple of resources for you, because I know that the next slide will be the last one, so I want to leave time for a couple of quick questions, but let me just show you a few things. All right, so this is the homepage, okay, so ignite.apache.org. And as you can see there, download, okay, so you can download the source or the binary, okay, nightly builds, Docker, cloud images, and so on. There's a whole range of options that you have available. If you download the binary, as I said before, just need Java, okay, minimum Java 8. An IDE is useful. I use the IntelliJ in the demos that you saw recorded. Using Maven it just builds. Right? There's very little that you have to add or very little that you have to customize in order to get this running. Everything will work standalone. Like I said, you can be up and running in 5 minutes. It's very, very useful. All right, other stuff to look at. So if you are interested in some of the kind of machine learning stuff that I've done on this, as well as in sort of an introductory article on TensorFlow, then I got a bit of space on dzone, okay? So just do a search on my name, and you'll get my space. There's about, what, 28 articles there. If we just scroll down a little bit, you'll see that there's a whole bunch there, which I wrote last year. If I just zoom in for you a little bit there and just have a look at this, okay? So k-means clustering. Apache Ignite machine learning for fraud detection at scale. That goes into a bit more detail into that short demo that I showed you, okay? And again, links to the GitHub code. I'll show you GitHub as well. And then some other examples, KNN classification, linear regression, and an introduction to machine learning. There is something on genetic algorithms there as well. Okay, it drills down to a bit more detail there for you. And so I think that's, for me, it's a learning process. Okay, like I said, I'm not a data scientist, but what I wanted to do is to try my hand at this, just to see how easy it was for me. And it wasn't actually too difficult. So yes, I needed to understand what was the best algorithm, if you like, for a particular problem that I wanted to investigate. But that's okay. You know, it's trial and error. Maybe I make a wrong choice. It doesn't matter. You know, you test it out, you try it out, see how it goes, and maybe there's something else that's better as well. All right, let's have a look at, yeah, so this is my GitHub space where, again, there will be links to all those articles to this code, okay? So it's all written in Java, and it's pretty straightforward, okay? There's nothing particularly exotic or difficult about this. What I've simply followed are the examples that are provided with Ignite. They come well equipped with these examples, so k-means, KNN, linear regression, logistic regression, which I used for the fraud example, for example, as well as all the data sets that I used to be able to generate that. In a couple of these cases, there's a bit of scikit-learn, some Python code there as well, because these were written a while back. They were updated few months ago, but as you can see, you're looking at sort of 9 months ago when this was originally created. Obviously, the world has moved on since then. The examples have moved on since then. Functionality has improved. A lot of the things that I had to do in terms of the train test split, for example, can do directly within the product. Now, you don't need an external tool to do that for you. That's very useful. And lastly, and I think just before I stop, so feel free to reach out, okay? So I'm on LinkedIn, on Twitter as well. So if you are so inclined, you're very welcome to reach out to me. If there's anything that I can help you with, I will do my utmost to do so. Would very much encourage you that if this kind of technology looks interesting for you, try it out, okay? Very, very simple to use, very simple to set up. There is a fabulous community surrounding this as well. So both the dev and the user lists are very, very active, okay? I think they're amongst the top 5 most active Apache list in terms of number of contributions and the level of questions that are asked and the answers. GridGain has about like 5 or 6 people that just sit there answering questions. That's their job, all right? Really help the people that sort of get to grips with this. So don't be afraid. It could be the simplest question in the world that you want to ask or the world's most hardest question. Just ask, okay? And then people will be able to assist you sort of community-wise. So that will be really useful for you. Okay, so I think I am pretty much out of time, and I'm conscious of, and I think if we just scroll down there, just leave time for a couple of questions for you. So the slides will be provided to the organizers, and yep, question.
Just a
yeah.
So this is essentially a question around this kind of no ETL concept.
Yes.
So for example, for machine learning, in a lot of cases, you strive for reproducibility, and that would require you to version and lock particular timestamps, your data, so you actually know what went into the training of particular model. So yes. Can you comment on how you can do it when the model, actually the data is persistent, you have like the streaming data coming in, so how would you do data versioning in that case? Thanks.
Okay, so the question is about data versioning, and in the event that you've got, say, streams of data, I think it was the example that you were giving, which is actually a good one. So say you've got a fraud detection system, but let's say these transactions are occurring in real time. The bank wants to see and stop fraudulent transactions as quickly as possible. So the data would be streamed in. We all have mobile apps. We all do online banking. So in this situation, I need to look at this specifically, how Sberbank are doing. But I believe, yes, timestamps are one mechanism that obviously the transaction has a date and time and a specific sort of in terms of where it took place. There's a lot of geographic information associated with that as well. The vendor and, there's a whole range of data associated with that. I think in this case, what you're trying to do is using this kind of continuous learning framework, you're simply trying to take an initial state, you build your model. As new data arrive, you're trying to iterate over that to try to improve the accuracy of your model. And so I think there's some issues associated with that as far as the data itself are concerned. Your model is only as good as the data that you can provide for it. So in the case of streaming data, I think there's always going to be an issue in terms of how much data you can consume. But what I can say with this is that Ignite is happy to, when you're working with things like Spark Streaming or Flink, Kafka, any of these streaming technologies, the operations can be parallelized. The timestamp that comes in is maintained on the data itself. There's no problem there. It will happily consume. You can define things like, what do they say? So, a window. So you can say, okay, I'm interested in the last 5 events, or I'm interested in the last 5 minutes worth of data. You can filter upon that based upon when the transaction occurred. There is some, I think, assumption in terms of how messages are arriving. There's no guarantee that they may arrive in a particular order. There could be some issues associated with that. For example, some things could be delayed. But if you look at things like Kafka, for example, there are things that it can guarantee that they are one time. It's almost like a transaction. It will do and it will confirm that yes, this happened this way. So in the case of Ignite, I think the technology relies less upon itself, but more upon the integration that has with something else. So I think the kind of answers you're looking for really would be the third-party tools that it works with. So in the case of streaming technologies, we would rely upon things like Kafka, Spark, Flink, and so on to maintain the information, maintain the data, give us what we want. And again, we assume that in terms of the accuracy of the data, maybe it's not a good assumption, but as far as model building is concerned, I think the emphasis there at the moment. Now, it will improve. There are some problems with that approach, but that's as far as I know at the moment. I can certainly dig into this for you and I can take this offline to discuss with you a little bit more, but I see where you're coming from and I can see the concern that you have. It's a great point. And we'll look into that for you. Right. And yes.
Great talk, first of all.
Thank you.
I've never used Apache Ignite, but I'm very proficient in Spark. Yeah. I'm also not a data scientist, but yes. Over the last 3 or 4 years, people ask us to implement in data engineering and big data a lot of crazy algorithms. So I end up realizing that the first line of discovery is easier with AutoML technology. So I use a lot H2O, which the guys that are here outside. Yeah. In Apache Ignite, is there any roadmap? Do you know if there is any roadmap at a point in time that they build a framework that can try as many different algorithms, variations, relations, variables, distribution of variables for the testing and the automation of the data science pipeline, which might take you weeks, and with like something like H2O, you reduce those weeks to a couple of hours, and okay, I might try this, I might try that. So is there anything similar on the roadmap for Ignite, especially with TensorFlows and stuff like that?
Okay, so the question is really asking about, the stuff that I showed you is very much me as a developer coding stuff and testing it out and trying it out. But are there any plans to automate some of these capabilities? At the moment, I'm not aware of those. I think where that automation comes from would really be to try to integrate with other vendors who already have done a good job. There is no point to reinvent the wheel. So one of the things that Ignite does, for example, is that where you've got, say, great streaming technologies such as Spark, such as Kafka, Flink, and so on, it doesn't reproduce them internally. It happily provides connectors and adapters for those. The other thing is that where the machine learning and deep learning integration was really driven was from customer demand. And they said, well, look, we're already coding. We've got expert Java developers. We've got all this huge quantities of data. Now we want to be able to do a little bit more with that. So that's the first phase that came as part of this. Now, it's a significant technical kind of addition, in addition to the SQL and the persistence they added. So I think what you'll see, particularly for the rest of this year, is the dust settling, if you like. They will really focus on making this technology bulletproof and as reliable as possible. And I think expect to see integration with other third-party tools that can help do a lot of the things that you've said. So the H2O guys, yes, I mean, they've solved that problem. For you as someone, or if I am not well versed in data science or machine learning, I want to be able to do this. Take the data, clean it up for me, let me create some models, test it out, get some insights and analytics from this, and do it quickly. Okay? I don't have the time. I'm not a Java developer. Imagine that I am the sort of manager. Absolutely, I understand that, and I think this is the direction that we really need to move in. And as I said right at the beginning, for you guys, do the next 10 years, and then get out, right? Because your jobs are going to be replaced. The tools are going to take over, and that's going to be end of data scientists, okay? So, but at the moment, I'm not aware of anything in that direction. I think partly because it's a community-driven project. The community kind of votes and decides where they want to go, what's the next bit of functionality that they want to add, and sometimes it's a little bit hard. If it's something that you really want, get involved, make your voice heard, and then tell them that you would like to see this kind of integration. Certainly as far as the roadmap is concerned, I can provide you with something a bit more detailed in terms of what's happening as far as the machine and deep learning is concerned. But I think expect to see the TensorFlow support becoming better. As I said, there is a focus on ensuring that what they've already added, removing some of the technical debt, for example, and ensuring that it is really bulletproof and it will work really well. But great question again. Thank you very much for that.
I think we've got time for one last question if anyone has one. Great. Let's thank Akmal.
Thank you. Great. Thank you.